start with a cough. Okay, so we've all heard about these things before. They're called angles. What do you already know about angles? All right, so don't worry about it. Don't worry about it. If I draw this picture for you, what did I just draw? What's the name of that shape? It's not a line.
It's the ray.
It's a ray. That's very good. This is a ray. Okay, very good. So if I draw another one of these rays over here and I connect them at this particular point right here, what's the name that we give to that point? The vertex. Very good. Your geometry teacher is proud right now. All right.
She got fired halfway through, so.
Oh, okay. So the space that is created between these two rays with a common point called the vertex, this is generally how we describe an angle. And that symbol right there you see is called theta. Theta is generally the symbol that is used to represent angles. There are a bunch of symbols that we can use, such as theta, gamma, beta, lambda. We're going to use all of those this semester. But this is the yeah, it's like a little zero with a line through it. And this is what our angle represents, okay? And our vertex is joined at the middle there. Now, when we draw an angle in geometry, there was always an initial ray and a terminal ray. So this would be, in my case, I would just label this one the initial ray and then call this one the terminal ray. And these rays were kind of just floating around in the coordinate plane. There was really nothing special about them. We would just learn how to define them this way. Does everyone remember that from geometry? No? No? You guys don't remember that? Oh. Well, okay, good. Now that we have this. So this is what our conventional wisdom of an angle how it's represented. In trigonometry and in pre-calculus, we're going to do something a little bit differently. We're going to lock down that initial ray, and we're going to call it in standard position. So that's what box number 2 is all about. Okay, in trig class, pre-calc, the way that we draw angles, we draw them in standard position so that we can all talk about an angle and know and understand what it means to describe and draw an angle. So the first thing that we're going to do is draw a coordinate plane. Okay? Draw a coordinate plane. Here's x, here's y. And as a refresher, which quadrant is quadrant number 1? Yeah, top right. Okay, what's quadrant number 2? Good. What's quadrant number 3? Good. As a refresher, quadrant number 4 is the only one left, okay? Now, look back to the very first box, right? We have two rays, we have a vertex. We have an initial ray, we have a terminal ray, we have a vertex, and we have that space between called the angle. Okay, if I was going to put the vertex somewhere that's really useful, where would you guess I put the vertex in standard position? At 0, 0. You're totally right. Okay, so now for us, we're going to begin by putting the vertex at the origin at 0, 0. It's good with that? Then what we're going to do is we're going to draw our initial ray, and we're going to glue it down to the positive x-axis. Okay? That's never ever going to move. The initial ray will be glued to the positive x-axis every time we draw an angle in standard position. That means that my terminal ray, my terminal side, is free to swing around the coordinate plane and end up wherever it wants to end up. So in this case, this would be an angle, and I would call that angle theta. You guys go with that part? All right. Let me give you a couple other examples, right? I could draw this angle here, this purple angle, and I could swing down this way, and I could call that angle lambda. Lowercase lambda, okay? One of these angles, and I want you to think about a clock. One of these angles moves clockwise, and one of these angles moves counterclockwise. Do you see that? Okay, talk to your neighbor right now. Tell me which one you think moves clockwise, which one moves counterclockwise. Okay, who's got an answer? A theta, which way does that one move? Theta moves.
Oh, wait,
Theta, this one's theta.
Oh.
That moves counterclockwise. Okay, that means that lowercase lambda there moves clockwise. Okay, now, one of these angles is a positive angle. One of these angles is a negative angle. All right, think about the quadrants and talk to your neighbor. Which one do you think is positive? Which one do you think is negative? Lambda or theta? What do you think? Which one's positive and which one's negative? Oops, I should do that in purple blue. So we'll go with theta here. Any guesses? What do you guys think? Positive or negative?
Positive.
Yep, that is actually correct, okay? Counterclockwise angles are positive. All right? If an angle moves and opens up counterclockwise, then that angle is a positive angle. Similarly, if an angle opens up clockwise here, then this is going to be a negative angle. So counterclockwise angles are positive, clockwise angles are negative. Alright, so to draw an angle in standard position that is positive, you got to have the coordinate plane first of all. Okay. Second of all, you got to have your vertex at the center. Your initial side is always glued down to the positive x-axis. And I asked for a positive angle, so it would be opening up counterclockwise. So that would be a drawing of a positive angle, okay? Give me a quick little sketch of a negative angle. Okay, so there's my example of a negative angle, something like that. You guys okay with that? Does it look out for you guys? All right, perfect. How many degrees all the way around in a circle? What do we know about that? 360 degrees all the way around, right? If I take 360 degrees, that is one revolution all the way around a circle, right? Okay, we know that. And a degree is, like you said before, something that we use to measure an angle, okay? So let's talk about 4 types of major degrees that we have to hit upon really quick, and then we can move on. So if I want to draw an angle in standard position that looks kind of like this, okay? And I call that angle theta. What type of an angle would that be? That'll be an acute angle, right? Yeah. If my degree angle is somewhere between 0 and 90 degrees, then I have an acute angle. Everyone remember that from geometry? Yeah, okay, good. In number 2 here, if I were to draw an angle that looks like this, so let's call that theta. Theta is between 90 and 180. What would that be? That would be obtuse, right? So 90 degrees less than theta less than 180 degrees. This would be an obtuse angle. All right. This angle right here represents what? Theta would have to be what in this case? A right angle. We call that 90 degrees, right? So we have a right angle. This is hopefully review. Is that true? All right. And then there's one more. What's the other one? What's a straight angle look like? A straight angle would be theta would have to be 180 degrees. 180 degrees. All right. Okay. There are actually 2 ways to measure an angle. One of the ways is called a degree, and we're all really good at that. And we just practiced with 90 degrees, 180 degrees, drawing 45 degrees. We can do all that stuff in standard position. A radian is the other way to measure an angle, and it's actually a much better way to measure an angle. So I'm going to give you my own personal definition of what a radian is, and then I'm going to give you the book's definition, and we'll compare the 2, okay? So what is a radian? Do me a favor. Do the best thing you can to draw yourself any circle. Oh, look, mine's going to be highlighter. That's cool. We'll take it. Okay. So draw yourself any circle that you can, right? Actually, I don't want this one. I want a real circle. There we go. Okay. Every single circle has what? It has a center. Very good. What else does it have? It has, what do we call this thing? It's called a radius, okay? So have I blown anybody away yet so far? No. Yeah? Circle and radius? Okay. All right. Now, here is my definition of what a radian is, okay? You guys ever seen Walking Dead?
Yeah.
No? You guys know what that is? It's a TV show. It's on TV. And there's zombies, right? Okay. So sometimes they chain the zombies to the ground so that the zombies can't walk and beat them, and they just sit there. So here's what I want you to think about, okay? Okay. Pretend that this little dot right here represents the zombie, and pretend that the R is a chain that is linked to the zombie's foot to a stake in the ground, okay? And let's say that zombie holds that chain tight because he's trying to go after you, right? What's the path if the chain is held tight? What path can the zombie take? Yeah, the path, he can just go around the circle, right? Around the edge of the circle, okay? Well, when that zombie, let's say that you're like over here, and that zombie starts going and starts coming after you, right? Like he's coming after you, right? When that zombie has walked the same distance that he's been given on the chain around the path of the circle, he has created 1 radian. Okay? That's a much easier definition, okay? So a radian is nothing more than the distance walked around the circumference of a circle that's equal to the radius of that circle. The angle that's created in between there is called 1 radian. So this right here is 1 radian. Does that make sense to you? It's actually a much nicer way of measuring an angle. And the cool thing is that it doesn't matter what size circle you have. The radian will always be the same because it's always dependent upon what radius you have there, right? Okay, so if this is 1 radian right here, if I just drew 1 radian, what would 2 radians look like? Yeah, it'd be something like kind of like this over here, right? Here would be like another radian over there, right? Okay. All right, so now this is 1 radian, right? So I've drawn for you 1 radian over here. So here's a conceptual question for you. Which is bigger, 1 radian or 1 degree? Which is bigger, 1 radian or 1 degree? Now remember, this was 90 with our hands, right? And then this was 1 degree. And I've drawn for you 1 radian up on the screen. Okay, so I'll go back to my 1 radian right there. So right now I want you to guess how many degrees you think 1 radian is equal to. Okay, write it down for me. Okay, let's do our guesses here. 1 radian. Give me a lower bound. What's the lowest anybody guessed? 30 degrees. Anybody go any lower than 30 degrees? Okay, 30 degrees. What's our highest? 60 degrees. Okay, so we think 1 radian is between 30 and 60 degrees, and that's just based on looking at the picture. I would agree. It's about there. It's between 30 and 60 degrees. Okay. Anybody want to go any closer, or you guys feel good with that?
45.
45, the lower bound. Okay, so 45, somewhere between 45 and 60. Okay, I'm good with that. All right, so let's continue on here conceptually what this is. So if this represents another radian, and this is another radian, how many radians all the way around the circle do you think there are?
3. Oh wait, 6. Sorry.
Yeah, if I was going to go all the way around, there would be about 6 radians all the way around the circle. Okay, about 6 radians. Okay. Okay, so let's explain this. So a radian is the measure of the central angle. So let's highlight that for you, tell you what that is. So the measure of the central angle, that's this measure right here, that blue angle that I just highlighted for you. So 1 radian is the measure of the central angle of the circle that intercepts the arc that is equal to the length of the radius. So that like that. Intercepts the arc of the circle equal to the length of the radius. Okay? Okay, let's talk about how to measure in radians now, right? So give yourself a circle, give yourself a radius, all right? And we're going to go around the circle, and let's give ourselves this angle here. We'll call this angle theta, and we'll go 1 radian. So we'll say theta is equal to 1 radian. And the way that I got that is by taking my arc length, which is r, this part on the outside, and dividing it by the radius. So that gives me 1 radian. So theta represents 1 radian. Okay? Let's go around here again, and let's go this angle. And let's call that angle lambda. And let's give ourselves another radian. So lambda is equal to 2 radians divided by my radius, which just gives me 2 radians. Okay? I'm developing something here. If I go again, and I go this angle over here, and I call this angle beta, and I give another radian. So beta is equal to 3r, which is the total distance around the circumference of the circle, divided by my radius, which of course gives me 3 radians. Okay? So the question then, in general, how would I say, like, let's say I had this arc length here, how would I measure that in radians, that green one there? Well, what would you do? If I called that arc length, if I called that distance, let's call that a distance of s, then the angle that's created is just s divided by r, because that's what I'm doing every single time here. I'm dividing by r and then canceling out. So in general, if I want to say a radian measure is equal to the length of my arc, so arc length, all divided by the radius. So in general, if I want to just talk about radians in general, if I don't know exactly what it is, I take my arc length, whatever it is, divided by my radius. So if I have a generic picture that looks something like this, and I have some angle in here called theta, and I have some arc length s, and a radius, then the way that we measure radians is theta is equal to my arc length divided by my radius. That's it. All right, so how are degrees and radians related to each other? All right, so if I have a circle, and if I go all the way around from start to finish, if I go all the way around, how many degrees have I gone? I've gone 360 degrees. Okay, I'm going to call that theta for now. All right. So 360 degrees is equal to 1 revolution all the way around. Everybody good with that part? Okay. What's the name that we call the distance all the way around a circle? What's the name? The circumference, right? Okay. So let's write this down. That we know that the circumference of a circle is equal to, what's the geometry? Remember that formula for circumference? 2 pi r. Very good. Awesome. 2 pi r. Okay. So the circumference all the way around is 2 pi r. Okay. So now, if I want to convert this to radians, look back up here. We just figured out that any radian measure, the angle is the s, which is the arc length, divided by the radius. Okay. So if I want to go all the way around, then it must be true that 360 degrees must be the circumference, which is 2 pi r, my arc length, divided by my radius. Look what happens to the r's, you guys. What do you get? R's cancel out. So it must be true that 360 degrees is equal to 2 pi radians. And there it is. There's the relationship that we can build from. 360 degrees is the same thing as 2 pi radians. Now, remember this back up here? When I asked you to guess, so we said how many radians are there in an entire circle? You guys said about 6. And what is 2 times pi? About 6, right? Because pi is 3.14. If we double it, we get 6.28, right? So 6.28. All right, good. This allows us then to make a lot of connections, okay? If 360 degrees is 2 pi radians, how much is 1 radian worth? If I divide both sides by 2 pi, look what I get. I get 180 degrees. 180 over pi is equal to 1 radian. Okay? So now remember back up here, you guys told me 1 radian is somewhere between 45 and 60. Okay? And we just learned right now that a radian is equal to 180 over pi. So you guys tell me, who's got a calculator? How much is 180 divided by pi? All right, so we just realized that 1 radian is now worth 57.3 degrees. So back up here, we were totally correct, right? It had to be between 45 and 60. 1 radian is now worth 57.3 degrees. All right? Okay, so this is a useful little chart that I came up with to help people how to convert from one to the other. So we're going to be working with radians and degrees throughout the entire year. And the first thing that we have to be able to do is convert from one to the other. So if we want to take a degree and turn it into a radian, we're going to multiply by a factor of pi over 180. So we're going to multiply by pi over 180, and that will give you your radian. Okay? If you have a radian and you want to turn it into a degree, you're going to multiply by, where we go? Sorry. Multiply by 180 over pi. So these are our conversion factors. So this little chart usually helps everyone to understand the difference. So if I have a degree and I want to turn it into a radian, we're going to multiply by pi over 180. And if I have a radian and want to turn it into a degree, we're going to multiply by 180 over pi. Okay? So let's do a couple of examples here. Okay, let's take 30 degrees and let's turn it into a radian, right? So if I want a degree to a radian, I multiply by pi over 180. So multiply by pi over 180. And that gives me 30 pi over 180. Zeros cancel. That gives me 3 pi over 18, which is just equal to pi over 6. So 30 degrees is equal to pi over 6 radians. Okay? Let's do B. Let's do 60 degrees. If I want 60 degrees, I want to turn it into a radian. I multiply by pi over 180. So that gives me 60 pi over 180. And that's going to give me pi over 3 radians. Does that make sense what I'm doing? Okay, everyone in the room here with your partner, give me 45 degrees. If I give you 45 degrees, give me the appropriate radian. There you go, exactly. So multiply by pi over 180. So that gives you 45 pi over 180. So that gives you pi over 4 radians. Okay? All right. Give me this one. Give me D. Or am I on D? Yeah. Give me 135 degrees in radians. Yep, you should have got 3 pi over 4 radians. Awesome. Okay, let's go the other way. All right, let's go the other way for you guys. Let me give you, if I gave you 11 pi over 6, that's a radian, okay? Take 11 pi over 6 and turn it back into degrees for me. 11 pi over 6, turn it into degrees. Okay, so to go from a radian to a degree, we're going to multiply by 180 over pi. Pi's cancel out, leaving with 11 times 180 over 6, which is just 330 degrees. Okay? Okay? How would you draw 390 degrees in standard position? Draw 390 degrees in standard position. Okay, so drawing 330 degrees in standard position, you should have your initial ray pinned down to the positive x-axis. If you go all the way around, you've gone 360, so you have to go 30 degrees more, and that would be at your angle theta is equal to 390 degrees. Does that make sense to you? Okay, good. All right. Draw for me, so the second one here. I want you to draw negative pi over 4 in standard position. So drawing negative pi over 4 in standard position, you're always going to start with this, okay? Here's your initial side is always going to be locked down to the positive x-axis, right? Negative pi over 4, it means going down 45 degrees in the negative direction. So that angle theta would be negative pi over 4 radians. You guys draw that correctly? Yeah. All right.